Hey guys, so 1.3 notes, we are going to do transformations of functions. We're going to start with one transformation at a time and then put a bunch of combinations in, and I'll show you how to do that with the table. Now, the other thing we're going to focus on too is that not all of our functions will be our normal parent functions. That's any function, just like this one right here. So right here, we're going to do a vertical shift. We're going to use f of x. This is f of x. And we're going to shift it plus 2. Okay? Now, that is a vertical shift. It means that we're going to move it up 2. So lots of times when you guys are doing transformations, it's good to analyze what the equation says first and then actually write down that movement. So up 2. Okay, now the other thing that is a good thing to do is actually when we're not dealing with a parent function, we're dealing with a random function, is to draw the original f of x first. So I'm going to draw that first. So 0, 1, 2, 3, 4, 3, 5, 1, 2, 3, 4, 5, 5. All right, yep. Okay. So blue is going to be my f of x, and now I'm going to move everything up. So I will do that in purple. Hopefully you guys can see the difference. So I take each of those coordinates and just move them up 2, 2, 2, 2, and 2. So here we just made a vertical shift up 2. Okay. Now, this is a mathematical way of saying it. So when you're adding something on the end, which in this case we'll call it D, it's a vertical shift, meaning up or down. If you're adding, it's up. If it's subtraction, it's down. Now, why is it that they call that D? Well, if you remember from last year and the year before, maybe one of your teachers might have showed you this, where I say A times f of bx plus c plus d. These are all the different transformations, A, B, C, D, that can be made to a function. And a vertical shift is RD. So let's keep going with other transformations that we can see what happens. Another vertical shift, well, this is a vertical reflection, okay? So as you can see here, it's a negative out front. And what does that actually do to us? It reflects it over the x-axis. So a negative out front reflects over x-axis. Okay, now I'm going to go back and I'm going to draw my original f of x. So 0, 1, 2, 3, 4, 3, and 5. Or what was it? What was that original point, guys? It was 5, 5. Sorry, 5, 5. Second guess myself there. Okay. Now, a vertical reflection just on the graph is the same distance away because we're reflecting it over the x-axis. So 1 away, 1 away. 1, 2, 3 away. So 1, 2, 3 away. 3 away, 3 away. And that's 5 away. So 1, 2, 3, 4, 5. And there is our negative f of x. It reflects that. Okay. Then we have vertical scaling. So this is a vertical stretch or shrink. This happens when you have a multiple out front. Not so if you look back to where we had this a times f of bx plus c plus d, a can have it affect the reflection of it, right? If a is negative. And then if a is anything but 1, then we either have a stretch or a shrink vertically. Vertically means it affects the y's. So let me write down our coordinates here. So 0, 1, 2, 3, 4, 3, 5, 5. I am actually going to do this by table and show you how to use that table. So our original x, y is 0, 1, 2, 3, 4, 3, and 5, 5. Now I said before, when we multiply on the outside there, it's going to affect the y value. And what we do then is that we are multiplying the y by 2. So we have 2, 6, 6, and 10. Now what I like to do is when I change something, I then mark it out so I don't look at those numbers. Because now what I'm going to do for my transformation is plot these points right here. So 0, 2, 2, 6. So 3, 4, 5, 6, 4, 6, and then 5, 5, 6, 7, 8, 9, 10. And here we stretched it by 2. So here is a stretch by factor of 2. Next page, if I can get it. All right, here again, it's on the outside, so it's dealing with y, but instead we're going to shrink by factor of 1/2. Okay, so let me draw the original. Let me do the table so I can see it. And it's on the outside, so we're still dealing with our y values. Okay. So now I'm going to multiply by 1/2. So I get 1/2, 1.5, 1.5, 2.5. Again, I'm going to mark that off so I don't look since I changed those y values. So I get 0, 0.5, 2, and 1.5, or 1.5, 5, 2.5. So it shrunk vertically. Okay. Now, so what that tells you guys is that when A is greater than 0, it is going to stretch. Okay, and then it's going to stretch. Now, if A is between 0 and 1, it's going to shrink or shrunk. Okay. If A is less than 0, you're going to do a reflection. And then you're going to do that scaled shrink or shrunk based on the number. Okay. So when we have multiple ones, we need to make sure that we can do them in the correct order, okay? So here it says graph f of x and plot at least 3 points. Use transformations and state the domain and range of G. Now, very, very specific, guys. It says plot at least 3 points. So don't just sketch it out. You have to plot 3 points. So I am going to look at x, y as our parent right there. So let's do some perfect squares, so we know we're dealing with good numbers. So 0, 1, and 4. Okay. The square root of 0 is 0. Square root of 1 is 1, and the square root of 4 is 2. So 1, 1, and 4, 1, 2, 3, 4, 1, 2. Okay. So this is our square root. Now, as you can see, we're doing a stretch by factor 2, and we're moving it down. So the question is the order. Well, they are both on the outside. Now, what I mean by outside is this is our original function. So as you can see, if I put that in parentheses, the 2 and the 1 are on the outside. So on the outside, you're dealing with the y values. And you do have to do it in a certain order. You always go from left to right. Okay, so we're going to multiply by 2 first, because that's on our left side. So we get 0, 2, and 4. Now, I just did a transformation, so I'm going to cross this out so I don't look at it. With the -1, I still have to do that to y because it's on the outside. So I'm going to subtract 1 from all of this. So I get -1, 1, and 3. Okay. So I'm going to cross that out because I moved it. Because now I'm going to plot my remaining points here. So I'm plotting 0, -1, 1, and that should be +1, right? Whew, luckily, oh, this way. This is negative. It's lunchtime, guys. Sorry. So right here, this is what confused me. Here we go. So 0, -1, 1, 1, and 4. So 1, 2, 3, 4. 1, 2, 3. And we did both of those transformations. All right, now we're going to go down to horizontal shifts. Okay, well, I forgot something because before we get into horizontal shifts, I forgot to do the domain and range of G. So domain is going to be, look, it starts at 0 and it's at 0, so that is a bracket, and it keeps going to infinity. And then the range will now start at -1, and even though it shifts off this way, it's still going up, just really slow to infinity. All right, now horizontal. Okay, horizontal is going to be shown on the inside. So you guys see how we see f of x here, and it has x plus 2? Well, you want to remember that on the inside, we are going to do that to x. And the thing is, we have to do the opposite to what we see. So we are going to use the original graph. So the original graph from f of x on the first page was 0, 1, 2, 3, 3, 3, and 5, 5. So since this is on the inside, I'm going to do it to the x value, and I'm going to do what's opposite. So instead of adding 2, I'm going to subtract 2. So 0 minus 2 is negative 2. 2 minus 2 is 0. 3 minus 2 is 1. 5 minus 2 is 3. Cross these out. And now I can graph my coordinates, which are negative 2, 1, 0, 3. Oh, this is 4, right? I messed up 4. If I do that, that means this one is 2, 2, 3, and 3, 5. So from the original now, we shifted to the left 2. So when it's on the inside, we kind of think of the opposite to what might happen. So that's why C, we're going to do the opposite, okay? All right, horizontal reflections. As you can see before, we did reflections, but we did vertical, and that negative was on the outside. Right now, our negative is on the inside. So what that tells us to do is reflect across the y-axis. So I'm actually going to do this through a table again, because on the inside, what side of the table do we do it to? We do it to the x's. So I have my x comma y. We have 0, 1, 2, 3, 4, 3, and hold on right here. Sorry guys, I know this recording looks like I'm going from one to the other, but I paused, I had a guess. So 5, 5. Okay, so on the inside, what do? We do it to the x value. So what are we doing? We're multiplying by negative 1. So we get 0, negative 2, negative 4, and negative 5. Okay, cross that out. Now I'm going to look at my new points. 0, 1, negative 2, 3, negative 4, 3, negative 5, 5. And what do you know? It's reflected across the y-axis. Okay. And again, the mathematical setting of what happened. Now, as we did the vertical scalings, the stretches and shrinks, we're going to do the horizontal. Okay. So remember, the vertical was multiplying by a number other than 1 on the outside. So here, for horizontal, we're multiplying on the inside. Okay. Now we're still using the graph f of x. So let me write down that table. 0, 1, 2, 3, 4, 3, and 5, 5. So before you start writing some other stuff down, I want you to remember it's on the inside, so we do it to x. So we're going to be multiplying to x, but here's the tricky part. Remember when we were doing our horizontal shift from left to right, and you did opposite to what you see? So if you saw an adding of the 2, we actually subtracted 2. This is going to be kind of the same thing, except when we think opposite, we're going to think reciprocal. So it's on the inside, so we're going to do the reciprocal. We're not going to multiply by 2. We're going to multiply by 1/2. So I get 0, 1, 2, 2.5, or 2.5. Okay. And here we would get 0, 1, 1, 3, 2, 3, 2.5, 5. So as you can see here for the horizontal, it actually shrunk. So it's the opposite to what we see. So even though it's 2 and we expect it to get bigger, it's on the inside, so it gets smaller, so it's a shrink. Okay, now what happens if it's 1/2? Let's do it again. X, Y, 0, 1, 2, 3, 4, 3, 5, 5. Okay, on the inside, so it's down to X. So we're going to multiply, but remember it's the opposite. Well, in this case, the reciprocal. So the reciprocal of 1/2 is 2. Okay, so 0, 4, 8, 10. Cross this out, so I remember not to use those numbers. And we get 0, 1, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3. 5, 6, 7, 8, 3, 10, 5. So look at that stretch. Great. All right, let's see if we can do another combination of stuff, right? So again, this is a mathematical sense that we are doing, you multiply by the reciprocal. So if I see b here, it's actually, we're multiplying by the 1/b, okay? So what happens is that's what we get. We stretch, we shrink, all that stuff, okay? All right, so now let's do a couple things. We are going to use our parent function of the square root of x. So as you remember from the table of the square root of x, we used 0, 1, and 4, right? And we get the square root of 0, 0, square root of 1 is 1, square root of 4 is 2. Now, this 2 and 1 is on the inside. I know it's on the inside because this is our function. So if I put parentheses around our function, I'll put parentheses around that square root. Now you can see it's on the inside. Okay? So since it's on the inside, everything's done to x. And just like we did with the with everything on the outside, you guys are going to have to do it in this case, you're going to have to go from right to left. Hold on one second. Give me a moment to reflect of this. Okay, I'm going to pause the video for a second. I'll be right back on. Okay, well, what is going on? Because now you see me in 2 of them. And of course, I'm recording, right? There we go. Okay. Sorry, guys, this is a mess, and this is what happens when I'm recording on Zoom. Luckily, it looks like I went right from the other for you, but I actually paused the video. My biggest thing is, remember on the outside, we were going from left to right. On the inside, I was just double checking, but On the inside, we do the opposite. Remember how we always do the opposite on the inside? Well, instead of going left to right, we're going from right to left. So we are actually going to deal with the 1 before the 2. Now, we're dealing with the 1. It says +1, but we know we have to do the opposite, which is -1. So if I subtract 1, and subtract 1, right? Let me extend this so I don't get confused like I did earlier. Cross this out. Okay, so I did the 1. Now I'm going to do the 2. I'm going to multiply, but remember I have to do the opposite, which in our case is reciprocal. And the reciprocal of 2 is 1/2. So I get -1/2, 0, and 3/2. If you don't like those coordinates, guys, you could go even one further. You could have said like, oh, another square root, a perfect square is 9. That would have been 3. And then subtract 1 is 8. Divide by 2 is 4, or multiplied by 1/2. That just gives me another coordinate to put down if I need it. So -1/2, 0. 0, 1. 1 and 1/2, 1, 2. And like I said, this allows me to make it look bigger by doing 4. 1, 2, 3. And now we have our transformation. Okay. Now let's put our transformations together. But be careful of the order and what side you're doing it to, okay? So I might use my highlighters in this sense to make sure I'm going in the correct order, okay? So let me do this. On the inside, I have my +3. On my outside, I have my -2, okay? So outside I do to y, inside I do to x. And I'm using the parent function. So it's still a square root. So I'm still going to use perfect squares. 0, 0, 1, 1, 4, 2. Okay. If I want, I can do the 9, 3. Now let's talk about x, y. So which one of these do I do to x again? I do the 3, okay? But of course, I have to do the opposite because it's on the inside, so it's a -3. I'm gonna go -3, -2, 1, and 6. And I'm going to cross that out so I do not look at those numbers. Now on the y, I have the -2. On the outside, I do the same thing as what I see. So I have this -2. So I go -2, -1, 0, and 1. Okay, now cross this out so I know what my coordinates are supposed to be. So I have the coordinates -3, 1, 2, 3, -2, 1, 2. I have -2, -1. I have 1, 0. And I have 6, 1, 1, 1, 2, 3, 4, 5, 6, 1. And there is our graph. Now it wants me to state the domain and the range. So domain, where do we start? We start at -3, and it does go through it. We go all the way to infinity because it keeps going. And then the range, our y starts at -2. And then it keeps going up to infinity. Yay! All right, let's see. I'm going to use my highlighters again just to make sure. So on the inside, I'm going to highlight blue. So on the inside, I have a -1/2 and I have a -1. On the outside, don't forget here, I have a negative. out front and a negative or -2 on the outside. Parent function. So x, y. So I have 0, 1, 4, and 9. I'm just going to keep that 9 in there just in case. So I have 0, 1, 2, and 3. All right, let's do my inside stuff first. On the inside, we have that 1/2 and that -1 there. Which one do we do first? It's on the inside. Inside, we do opposite to what we think. So we're going to go right to left. So on the inside, we're going to start with that -1. We've got to do the opposite, so we're going to add 1. So 1, 2, 5, and 10. Then we do that 1/2. Now it's multiply, but we have to multiply by the reciprocal. So we're multiplying by 2. So 2, 4, 10, 20. Okay. Now let's talk about our y's. We have a negative up front and we have that -2. Remember, on the outside we do the y, but we also go in the order from left to right. So I'm going to multiply by -1 first. Okay. Then we have this -2. It's on the outside, so we do exactly what we see, which is -2. So we get -2, -3, -4, and -5. See why I cross them out, guys? Because I'm having, so that way I'm just looking at the outside for the coordinate pairs. So 2, -2. 4, -3. 10, -4. Okay, so we are actually going like that. Now we need domain and range. Domain, well, where does our point start? It starts at 2 and goes to the right, so that's infinity. And our range, well, our range, be careful, remember it goes from high to low, but this isn't the low, this is the high. The low is that arrow that keeps going down, so it actually starts at -infinity and goes up to the highest is -2. All right. Hopefully we're almost done here, guys. All right, on this one here, below is a complete graph of y equals f of x. Use it to graph this function here. Okay, so this looks really complicated. Oops. This looks really complicated from, remember how I showed you at the beginning how we had this a times f of b x plus c plus b d. Okay, that's kind of how we want to put this. So let's rearrange this a little bit. So this would be 4 divided by 2 is 2 minus 3 divided by 2 is 3/2. And then we have this f of 1 minus 2x. Okay, now again, still a little bit off. So I'm going to say -3/2 f. Then I'll have this -2x plus 1 plus 2. So I just rearranged it so we know how to do our scale from our tables. Okay, so x, y. Okay, I have -4, -3, -2, 0, 0, 3, 2, 0, and 4, -3. All right. I would say do this by doing either the inside first or the outside first. So I'm going to stay in the same order we did with the last ones, and I did the inside first. So I have to deal with a -2 and a 1. It's on the inside, so which one do I start with? I start with the 1. Since it's an adding one and I have to do the opposite, I subtract 1. So I get -5, -3, -1, 1, and 3. Then I'd have to do the -2. Okay, I can do the negative and the 2 at the same time, but it's not 2 we have to deal with because it's on the inside. It's going to be 1/2. So it's times a -1/2. Okay, why didn't I scratch that one out? Look at me. I mean, I'm going to scratch it out eventually, but okay. So that means a negative times a negative is a positive. So we get 5/2, 3/2, 1/2, -1/2, and -3/2. Okay. And now my y, on the outside here, remember which one do I first? Do I do the 3/2 first or do I do the 2? I do the 3/2 first. So I'm going to multiply by a -3/2. So I get 9/2, 0, -9/2, 0, and 9/2. I'm going to add 2. This is where you guys might want to use your calculators just to be faster. Okay, just don't forget you're not using a graphing calculator. And since you're going a fraction plus a whole number, put those parentheses around the fraction when you do this in a calculator. When you do that in the calculator, you get 13/2, 2, -5/2, 2, and 13/2. And now you have your coordinates to graph. So we have 2.5 here, right? 1, 2.5, and then I'm going to go 6.5. 1, 2, 3, 4, 5, 6.5. And go 1.5, 2, and go 1/2, and then go 1, 2.5. Then I have -1/2 at 2, and -3/2, so 1.5 at 13. And there we go. We just did it. One more page, guys. One more page. All right. So here we have f of x equals x squared. Find and simplify the formula. So we're going to do this in steps, okay? We're going to create the equation, the transformation equation based on what transformation it wants, okay? So we're going to do a vertical shift of 2 units. Remember, vertical shift means we're actually going to add 2 to the outside. So we go f of x plus 2. Then we're going to take this and move down to the next one. It wants us to reflect across the x-axis. Remember, that's a negative on the outside of things. So I'm going to go a negative on the outside of things. So here right away, I think what I'm going to do, guys, is I'm actually going to replace f of x here with x squared plus 2. Okay, so that means I have negative x squared plus 2. Remember, because this is on the outside and this is on the outside. Okay, then we're going to do a horizontal shift up. So not up, I meant right. So remember that's on the inside. So I'm going to have this x minus 1 squared. You still have that negative on the outside, plus 2. Because right means a minus 1 on the inside. And then we're going to do a horizontal. Horizontal means on the inside, guys, inside. So, and it's a factor of 2. So that means I have to do the reciprocal, which is 1/2. So I have negative x minus 1 squared. Oh, I forgot the 1/2, guys. Crazy me. Okay, and then plus 2. So there, of course you can't see it. Here is your horizontal shift at a factor of 2. Here's your movement right. Here's your moving up. And here's your reflection. Perfect. All right, guys, try that practice out.